Hello folks, this is Nikit and Shiksha, and here we present a short demo for assignment 3 of class CSE 530. In this assignment, we have developed a barrier synchronization mechanism on the kernel side which is invoked by user processes via syscall interface. We have to make sure that there is synchronization between all the threads and its iterations using this barrier on the kernel side. Three important syscalls here are barrier init, barrier wait, and barrier destroy. So as you can see on this file syscall underscore 32.tbl, we have three syscalls: barrier init, barrier wait, and barrier destroy, each having the numbers 351, 352, and 353 respectively. These numbers will be used while doing a syscall from the user side. Moving on to the next file syscalls.h. Here we have the same syscalls: barrier init, barrier wait, and barrier destroy, and each having its own declaration. And now we are moving on to the user side. So on the user side, we are forking two processes, and each process will call a function where we are doing a barrier init syscall. So what exactly are we doing in the barrier init? So when we go to the kernel side, we have a list which stores the processes, which stores the child processes as well as the barriers. So from the user side, while doing the syscall, we are sending the total number of threads which the kernel barrier will be expecting, as well as we are sending the barrier ID. And this is how the barrier init works. So each process on the user side creates a set of 5 threads which goes to one function, and a set of 20 threads which goes to another functions. When these threads go to their respective function, they call for a barrier wait on the kernel side. So what exactly happens is that when the threads on the kernel side hit the barrier, one by one they sleep till the last thread of that particular set comes and wakes them up. Then these threads goes for the next iteration, and this ensures that there is a synchronization between each iteration. We have a barrier destroy after this, which will destroy two barriers per process, and after both the barriers have been destroyed, it will go and destroy the child process of the kernel side. So this is the implementation of barrier init, wait, and destroy. So I'll will have a look at the user side. So here I am forking my first process, and this process will go to the process function 1, and will go to child underscore process underscore function. And in this function, we are doing a syscall for our barrier init. So on the barrier init, on this syscall, we are sending the number of threads as well as the barrier ID. Okay, now we are creating 5 threads. As I said, each child will create 5 threads as well as 20 threads. This set of 5 threads will go to function 1, and then in the function 1, for the 5 threads we will be doing 100 iterations. That is, one thread will be doing 100 iteration each, and while doing the iteration, it will do a syscall, which syscall of barrier wait, which will make sure that there is synchronization between each iteration. Moving on, in the same child process which I showed you earlier, there is another creation of 20 threads. This is another set, and this will go to function 2. The same thing will happen for the 20 threads. As it will make a syscall for the barrier wait, and same thing will happen. So after the control comes back, we will have to destroy the barriers, so we'll make a syscall for that, and after that happens, we will make sure that my processes on the kernel side have been killed. So here I have compiled my user program, and now I will be running my user program. since we have to take the sleep time from the user, we are giving a sleep time of 1 second, which is these many microseconds. So as we see, that was, this is iteration 2, this is iteration 3, this is iteration 4, this is iteration 5, and this will go on till 100 iterations. So as you can see, after my one iteration, like right now it went for 23rd iteration and now 24th iteration. If we wouldn't have used the barrier, it would have been haphazard. Like sometimes it would be one iteration and sometimes it would be two and then again one iteration, so all the threads would be doing its own iteration at its own time. But here we are making sure that there is synchronization between each iteration. Hence this serves the purpose of the assignment. Thank you so much.